converges or diverges, and tell me why, and show me why. Do you see? I'm not asking you what the limit is. I just want to know, does it have a limit? But with a geometric series, this is one of the only ones where you can determine that. So what you would say is, you would work that problem out like that, and then you would state, you have got to state for me, I need to see either the word converges or diverges, and then I need to see the word because. Okay? That's going to be the directions on the test. It just so happens that on a geometric series you can find the actual real sum. But almost every other one, you can't. You just need to know that it converges. And I'm going to show you what you will see on test 3, why it matters whether it converges a lot or not. Okay? So that's sort of the ground rules. Converge or diverge, and show me why. And showing me why is not that I put it in the calculator and I got that. Okay? I'll tell you something you can do. Ed, doesn't the calculator have a sigma feature?
I'm not sure. That's the thing. I'm trying to figure that out.
Okay, that's your homework assignment.
Okay.
I'll look too. I've got a manual.
Well, they've got, you know, that thing with the modes, they've got something called a sequence.
Yeah.
But I don't know what it does. It puts little dots on the screen.
Wouldn't it be nice if they had a sigma feature that would give them the sum of the first 10,000 terms? Wouldn't that help you know what the real sum is?
And I just got to say, the calculator sometimes can help you whether a sequence does,
Yeah.
but sometimes it doesn't.
We'll look at that.
It could be misleading.
Okay. Everybody follow what we did?
So we always can get an A and an R?
Yeah.
But
For every geometric series.
Okay, so other series you might give us something different? Or?
Yeah. Oh, yeah. You won't get an A and an R.
Okay.
Yeah. This, William, think of this as chapter 8 again,
Oh, okay, sure.
where all I'm doing is showing you different methods to do things, and they're all independent. Each method works for a different type of problem.
Okay.
Okay?
I show that to them. We found a summation button.
Okay.
It's on the TI-84 Silver Plus.
Okay.
So I don't know if it's...
Dr. Thomas and I'll play with it and we'll tell you about it. Here's what you might think about. If you took the sum of a series at 10,000 and then took a sum of it at 20,000, then those two would tell you they should not change dramatically because if the series converges, right? I'm just trying to get, I don't mind you using technology to check your answers, but as I say again, try writing that out on the test and see how far it gets you. Here's one, William. This is example 2 on page 564. And that is, I want to know, does William asked me, did you hear William's question? He said, are we always given an A and an N? And I said, yes. I probably should have said, Yes, either you're given it or you can find it. That's probably what I should have said. Okay, so watch what happens. Number one, do you know why I put the index on the sum? I couldn't just do the sigma, could I? Because that only works in one case and one case only. So I'm saying that the series S is equal to, and now I'm just going to write out a few terms. I think that is the first term with n equals 0, is that 5? Do you agree? Minus 1 to the 0 power, any number to the 0 power is 1, right? 4 to the 0 power, any number to the 0 power is 1, so don't I have 1 times 5 divided by 1? Everybody? Am I unconvincing, William?
Yeah, I agree.
Okay. Now n equals 1. I think that is minus 5 over 4. What do you think? Agreed? And what, I've already made a mistake. What's my mistake, Travis? That's it.
Why do you have a break?
That too. I started it out like a sequence, thank you. Remember, sequences have brackets, series have plus signs. That's just habit. You'll break the series, the sequence habit. Now n equal 2, doesn't that mean, doesn't that mean I get a plus sign here? And I get plus 5 over 16. Is that right? And then I get minus 5 over 64. And then I get plus. This is what's called a what's called an alternating series. Do I need to say another word about that, or do you? Isn't it pretty obvious why it's called that? For right now, that's all I'm going to say about it. It's just called an alternating series. There is a whole section, like 10.5, that deal with alternating series. But for right now, that's just nice to know thing. Okay? Now, here's what I want to know. Take those two terms and tell me, what did I multiply the first term by in order to get the second term?
Negative 1/4.
What did I multiply the second term by to get the third term?
Negative 1/4.
What did I multiply the third term by to get the fourth term?
Negative 1/4.
Doesn't that answer your question, William? So would you say that A0 is equal to 5 and R is equal to negative 1/4? Do not check just one term. Check 2 or 3 terms. I'm going to show you why in a minute. But I'm telling you, you can have 2 or 3 terms at the first of the series that are not geometric, and then it picks up as geometric from there on. So don't test just one term, okay? Now you know exactly what to do, don't you? And that is the sum is equal to A naught over 1 minus R, which is 5 over 1 plus 1/4, which is 5 divided by 5/4, which is 5 times 4/5, which is 4. That is method number 1. Method number 1 is real simple. Look for a common ratio. And if you get it, you say, hooray, because that is by far the easiest way to determine if the series converges. So what you would say is the series converges. Remember I said I have to see the word converges or diverges, and then I have to see the word because it is geometric and the absolute value of R is equal to the absolute value of minus 1/4, which is equal to 1/4, which is less than 1. Now you know me. First thing, you can't just tell me because R is less than 1/4. Why? Because there's only one kind of series in all of the series that we deal with that has an R. So you first have to tell me it's a geometric series. And that's what entitles you to use R. Does that make sense to you? So you got to say, I'm entitled to use R. You don't have to say that. You're saying that when you say it's a geometric series. It is a geometric series, and because it is a geometric series, here's why I know that it converges or diverges. Okay? All right? I can't make that hard, can I? I can muddy it up. Yeah, I really can muddy it up, but I can't make it hard. We've got just a few more minutes. Let me see if I find one I like. This is example 5 on page 565. Now, I'm going to do example 4. 565. And that is, I'm going to say, write 5.232323 as a fraction. How would you do that? How would you do that without calculus, without this section? There's any calculus in this, except a little bit in infinite series. How would you do it? Well, you'd put in 5.23232323 for as many numbers as you can get on your calculator and change it and hit that, change it to a fraction, right? Isn't that the way you do it? Yeah, I understand. Try that and see if it works on the test. How else do you do it? How else do you do it? Dr. Thomas?
Well, I was gonna mess with one sophomore in high school, but you didn't want that. You gotta-
No, I want you to tell them that method. I'm asking you to remind them of that
What
method.
I would do is I'd split the 5 off, okay?
Yeah.
Put it on the side.
First, Dr. Thomas says ignore the 5, right? There's no need to have it there because you just take the 232323 and make that a fraction, and then at the end put a 5 in front of it, huh? Okay, go ahead.
The way we learned in sophomore in high school is if you got 2 digits repeating, multiply everything by 100.
So, watch. Dr. Thomas says multiply everything by 100, right?
Mm-hmm.
So if you multiply by 100, don't you get
3.23.
now what?
You do your subtract. I'm trying to think, the answer is going to be 23 over 99. I'm trying to figure out how to set it up.
You remember?
No, it's.
Let's see
want
if
that.
I do.
Okay. Now,
Beth?
or you can break
Do
it
you
up.
remember? Guys, this side of the room is having a senior moment. Beth less senior than Dr. Thomas and I, but a senior moment. I always thought you subtracted, Ed.
You do. I'm trying to. You got to put 101 somewhere involved in that to get the answer 23 over 99. You could say, let n be the small number. Let 100n be the larger number. Subtract the 1n from the 100n. You get 99. N equals 23, and so n equals 23 over 99.
Dr. Thomas and I'll tell you about this on Wednesday. Here's how we're going to do it in calculus. What I'm going to say is, I'm going to say, that means I'm doing 2, 3, 2, 3, 2, 3. Do you agree? And I think that that is equal to a series that starts at point 2, that starts at, yeah, I'm going to use point 2, 3. It starts at point 2, 3. Then the next term is point 0, 0, 2, 3. Would you agree? Everybody? And the next term is equal to point 0, 0, 0, 0, 2, 3. When you add those, don't you get 0.232323? Is that right? Now, what I want you to notice is, what did I multiply the first one by to get the second one? Is that true? Do it, if you don't believe me. Do 0.23 divided by 100. What did I do to go from the second one to the third one? Same thing. Isn't that looking like a common ratio to you? So don't I know that A is equal to 0.23? And R is equal to 1/100? Is that true? So then S, the sum of that series, is equal to 0.23 divided by what? 1 minus 0.01, isn't that 100? 100th, is that right? So now don't I have 0.23 divided by 0.99, which is 23/99. So then we have our answer. Do you see how we used the geometric series to do that?
Are we gonna leave it as a mixed fraction, or do you want? just a
I'll
fraction?
leave it as a mixed fraction, I don't care. That's a pretty easy way, isn't it? And evidently for Dr. Thomas, Ms. Voss, and myself, it's a lot easier than the other way, because we can't remember the other way.
You come back in a few minutes.
Yeah, it'll come back to us
Synthetic division.
between now and Wednesday, it'll come back to us. That's the thing about old age. It comes back if you wait on it long enough. Okay, questions?
The way that you did this, I feel like you just kind of chose to do that. You didn't like you do what you did in the past by like keeping what you had and then adding.
I did what now? Say
just-
it again, William.
You just when you had the 0.232323, you just added.
Yeah, what I was doing when I did this is I said, this takes care of those first two, doesn't it? Right?
Right.
So then I needed to take care of the next two. But the next two had to have 2 zeros in front of it, and then the 2, 3. Do you see what I'm doing?
Right.
That's where I got it.
So we weren't doing kind of what you're doing earlier, where you were like keeping your original amount, but then adding.
Well, isn't that it? This is the, oh, I see what you're saying. I see exactly what you're saying. Yes. What I should have said is, I don't want to add them just yet. All I want to know is the common ratio.
Okay.
I'm sorry, I said yes and I shouldn't have. No, I don't want to add them just yet. I want to do the common ratio. And what we were doing earlier when I added them was I was making a sequence of partial sums. And here we're just doing a series.
So at the end, and that's 5 plus 23/99, right?
Yes. Yes. But isn't that 5 and 23/99? Isn't that what it is? Okay? See you Wednesday. Ed, I know you subtract them.
Yeah.
I know you do, but obviously, if you subtract them,
You do the bigger minus the smaller.
you know what you do? I think I just stop